All right, since I'm not available to go over the homework with you, I thought I'd go over some of the questions on this video, see how it goes. Maybe someone will watch it. I don't know. So, it looks like, as of so far, refresh. Whole lot of numbers 2, 3, 12. Maybe I'll sort of go through it. Let's just go through it. A proposed mechanism for the destruction of ozone. Which of the following is evidence that the mechanism is occurring? The presence of chlorine increases the rate of the overall reaction. So if we look at what's going on here, the things that get canceled out, the chlorine gets canceled out, ozone doesn't, the hypochlorite gets canceled out. So in this case, this is a catalyst, and this is going to be an intermediate because it forms and then it's destroyed. And so what does a catalyst do? It increases the rate. So that'd be answer choice A. Going through number 2, we've got the decomposition of N2O5, where this is the rate law. Right away, I see that because there's not a exponent, it's a first order reaction. They give us the concentration over time. So if you were to graph a first order reaction, the concentration would be our exponential decrease. That's what you would expect to see. Determine the value of the rate constant for the reaction. So you need to know that it's first order, and you need to know from your reference sheet how to get the equation for first order. So that's going to be the natural log of concentration of A at time t minus the natural log of the concentration at initial time equals negative kt. And down here, I've already solved for negative k. And when you plug it in, I chose the first and the last. It doesn't matter. They're all going to give you the same value. But natural log of 0.02 minus natural log of 0.16 divided by the total time difference, which is 5, gives us the negative 0.416 per hour. How did I know that it was hour to the negative 1? Well, you could do it a couple of different ways. If you did rate equals K times the concentration of A for the first order, yes, then molar per hour equals K times concentration in molar. When I solve for K, I just have 1 over hours as my unit. The other way you could do it, like we've seen before, is to know that a zero order reaction is molar per second or molar per time. A first order reaction is 1 over time, and a second order reaction is 1 over molar times time. But in any case, negative 0.416, 1 over hours is going to be well, actually, it's not negative, but there, your 0.416. Part B. Here's the mechanism. Identify which step is the rate determining step. Justify your answer in terms of the rate law given. So I know that the rate law is just the concentration of N2O5. And with elementary steps, because only simple interactions are involved with each elementary step, I can just say, here is one particle. The rate law is whatever's going on with that particle. Down here, I have 2 particles. The rate law is whatever's going on with that particle times whatever's going on with that particle. So that's what you can see I write over here. And then for the third one, I also have 2 particles. So this first one is the only one that matches the overall rate law that was given, which means step 1 must be the slow step. They told us the rate law of the elementary step 1 is this, which is consistent with the first order kinetics of the overall rate law. For part C, if the experiment was repeated at the same temperature but with twice the initial concentration, would the value of K increase, decrease, or remain the same? Explain your reasoning. Well, considering that rate equals K times the concentration, if I increase this, it will, well, I could draw that as an increase. If I increase this, that will affect the increase, or the rate, but it won't affect the K value. Remember, outside of weird nuclear reactions, the only thing that's going to affect your K value is temperature. We are not messing with the temperature, so it will be the same. All right, moving on. Number 3 got a lot of votes, right? Yeah. This one was really wordy, but we have a proposed mechanism with a slow followed by a fast reaction here in steps 1 and 2. And it says step 1 involves the collision between nitrogen dioxide and fluorine molecules. This step is slow, even though such collisions occur very frequently in a mixture of these two things. Consider a specific collision between a molecule of NO2 and a molecule of F2. One factor that affects whether collision will result in a reaction is the magnitude of the collision energy. Explain. And this is the really short version would be you have to overcome activation energy. So the magnitude of the energy is either high enough to overcome activation energy or not high enough, and that will determine. They wrote it with a lot more words here, but successful molecular collisions must have sufficient energy in order to result in reaction. Only collisions with sufficient energy to overcome the activation energy barrier will be able to reach the transition state and begin to break the fluorine-fluorine bond. So, overcome activation energy. Part 2, identify and explain one other factor that affects whether the collision will result in a reaction. We said the 3 factors are they have to collide, they have to have enough energy, and they have to have the correct orientation. So the short answer is the word orientation. The identify, that was really just identify. The explain would be for a collision to be successful, the molecules must have the correct orientation. And then they went into further detail of specific parts that would need to interact. If we jump into part B, consider the following potential rate laws for the reaction. Circle a rate law that is consistent with the mechanism proposed above. So you look at the slow step, you have the concentration of that times the concentration of that, and that's going to be what's going to affect your rate. What else? Number 4 only has 1 vote so far. You can do it quickly. So trying to figure out what NO is. NO was added at the beginning and it still exists at the end, and yet it cancels out, which means it wasn't used up in the reaction. That makes it by definition a catalyst. And for clarity, NO2 was formed and then used up. So it was not added by the scientist and it was not found at the end. That just makes it an intermediate. Those other 2, A and C, are red herrings. Number 5. Based on the models, which of the following represents a species that acts as a catalyst? So really, they just drew pictures instead of creating the chemical equation. So the catalyst has to be added at the beginning and it still has to exist at the end. So that would be just this white chlorine atom, chlorine ion probably. And that's why the answer is C. Number 6 continues the same thing. Based on the proposed mechanism, which of the following best describes the concentration of the species represented above as the reaction occurs? So what about this chlorine monoxide? So the chlorine monoxide was formed in step 1 and then consumed in step 2. You never actually see it as in the reaction, so it is only an intermediate. What is happening to the concentration of the intermediate? Well, if it's formed and then immediately consumed, then you would never expect it to rise very high in concentration. So as a result, the concentration will be very low for the duration of the reaction. And then for this same equation, what is the rate law for the destruction of O3? Well, you just look at the slow step, and it would be the concentration of ozone and the concentration of the monatomic chlorine. Ozone, chlorine. So D is the answer. Checking back in, we need to get down to number 13 pretty bad. See how quickly we can answer some of the others. Number 8, which of the following observations would support mechanism 1 but not mechanism 2? So it's all about the reaction rates. So when you look at mechanism 1, the slow step, I have 2 nitrogen monoxides, so the rate would be K NO squared. Over here, it's nitrogen monoxide times bromine, so K NOBr. So what is true of 1 but not true of 2 is that the bromine does not affect the rate of 1, but it does affect the rate of mechanism 2. When you go through here, what are the products? You go through and cancel everything out. The things that exist on the product side but not the reactant side are 2 cerium ions and 1, what's that, thallium ions? I don't know TL off the top of my head. 10. A reaction is determined based on the information above, which of the following is true. So the rate law is just K times X2. So I look at the slow step, that one is K times X2. This one is also K times X2. So that means both of these possible mechanisms are going to be the same as far as rate. Looking at number 11, which of the following rate laws for the overall corresponds to the proposed mechanism? So you just grab the slow step. It's the same thing that we saw up above, chlorine times ozone. So it's answer of choice B. On 12, proposed mechanism can be written in a more general form. What other species can decompose? So this is actually not a Unit 5 question. It's just a general periodic table question. What is going to be the most similar to chlorine is going to be something that's in the same column on the periodic table. So another halogen is your best guess. Number 13. When the concentration of substance B in the reaction above is doubled, all other factors being held constant, it is found that the rate of reaction remains unchanged. The most probable explanation for this observation is what? So it says substance B, the concentration has no effect on the final rate. So you could say probably the rate would be K times A, or maybe K times A squared, but B is not involved. So why would that be? If we look through our answer choices, the order of the reaction with respect to substance B is 1. Well, if it were 1, that would mean a B would be in it, and changing the concentration of B would change the rate. So that doesn't work. Substance B is not involved in any of the steps in the mechanism of the reaction. It wouldn't make sense to write it down in the equation if it's not involved at all. Substance B is not involved in the rate determined step of the mechanism, but it is involved in subsequent steps. So we've seen stuff like this before, where perhaps B is a catalyst. If you had the 2A plus B yields 2C, maybe your mechanism is going to be something like A plus A forms C, and B plus C, that doesn't make any sense. C plus D, and B plus D is another C. This would be a possible mechanism where if this is the slow step, then B, when we cancel stuff out, you have the D's canceling out. Your B gets added in the fast step, which means it won't affect the rate. So C is a possible choice. Substance B is probably a catalyst, and as such, its effect on the rate of the reaction does not depend on its concentration. We actually have seen other cases above where the catalyst, like here, chlorine is a catalyst. The catalysts can still, their concentration will affect it. So a more concentrated catalyst will have a greater effect usually. So that means C is our best answer choice. Trying to go quickly through this. We've got most of them. People are going to care about 15 a lot. 14. Which of the following could be the first elementary step of a two-step mechanism if the first step is slow? So the rate law is going to involve one NO2 and one F2. So there's no NO2 in that one. There's no F2 in that one. There's too many NO2s in that one. So B is the only good choice. Looking at 15. The elementary steps are below. Which of the following is the rate law for the overall reaction? So because I have 2 copies of NO2, the rate law is going to be K times the first copy times the concentration of the second copy, which could also be described as NO2 squared. And as a result, the final answer is B, K NO2 squared. Because I'm close to the end, there's only 18 of these. 16. Here's a reaction based on kinetics. Here's a proposed mechanism. Which one is consistent? So I just look at the slow step. I have an HBr that will affect it and an O2 that will affect it. Answer choice B is the only one that only includes those 2 reactants. Same thing with number 17. I have NO2, but there are 2 of them, so it needs to be squared. Points us to answer choice B. And then number 18, possible mechanism for the overall reaction is shown below. This time it's NO plus NO, which is also described as NO squared in a rate law. These division things right here seem like that would be nonsense, but you'll see on your next homework that that does sometimes come up in some respect, and you'll be able to look at that tonight. All right, I'll be on Teams off and on today. Reach out to me if you have any questions. Okay, bye.